These are the supplemental notes for the 11-11 standard deviation. Let's jump right into it.
Okay, so these notes are going to show us how is the spread of the data. So we talked about the mean and the median and the mode. And then we also talked about the range. So standard deviation is a type of range of a data. It's the spread, how spread out the data is. So standard deviation is represented by the Greek letter sigma. It looks kind of like an upside down Q. So standard deviation is the average distance between the mean and the data value. The variance helps us find outliers and gives us an idea of how the data is distributed. The standard deviation shows that the majority of the data values are above or below the mean of the data. Okay, so how do we calculate standard deviation without a calculator? Because sometimes you will not have one. So we first have to find the mean. So we add up all the data points and divide by how many there are. Then we're going to subtract the mean from each data point. Then we're going to square the difference. So we're going to take the data point, subtract the mean, then square it. Okay, then we're going to add up all of those numbers together, divide by how many there are, and then we're going to take the square root. So the variance is that number before we square. And then the standard deviation is the number after we square root. Okay, but with a calculator, it's a lot easier. We use a statistics calculator to determine the standard deviation. You enter the set of data into the table. Make sure that you clear the data before entering. Then the calculator displays the standard deviation using this sigma, the upside down Q. So this will help us analyze distributions. So distributions can be symmetrical or skewed. So if it's right skewed, it means most of the data is actually on the left because the smaller data is skewing it. It's pulling it this way. The tail of the data is on the right. Symmetrical means that the mean is in the middle. And then left skewed means that the tail, the short end, is on the left. Normal distribution. So a normal distribution is a symmetrical distribution where the mean equals the median. It is the mean plus the standard deviation will give us to the next point. So let's look at our examples here. So which of the distributions is left skewed? So remember that left skewed means that the tail is on the left. So we can automatically eliminate this one and this one because they are not skewed. This one has the tail of our data on the left. So that is why this one is left skewed. Amy's found the mean of her math scores, of her 11 math scores for the first. Okay, using 81 as the mean, find the variance of her grades round to the nearest hundredth. Then find the standard deviation of her grade. So we are going to do this without a calculator. Or we can use a calculator, it's up to you. But this one, we are not using a calculator. So what I'm going to do is I'm going to take each data point. I'm going to take 76. And I'm going to subtract the mean, which is 81. And then we're going to take that number and we're going to square it. Then I'm going to add that to the next value. And I'm going to keep repeating that process. So then I'm going to take 87 minus 81 squared, 65 minus 81 squared. We're going to find all those points, add them up, then divide by how many there are. So I'm not going to keep doing this. You can do that. And we're going to get the sigma squared equals 71.36. So this is before we square root. Then we are going to take this value and square root it to get the standard deviation, which is our sigma equals, and if we square root that, we're going to get 8.45. Okay. Henry recorded the number of miles he biked each day of the week. His miles were 25, 40, 35, 25, 40, 60, and 70. Enter the data into the statistics calculator. What is the standard deviation of the miles Henry biked to the nearest tenth? Okay, so now we are going to use our statistics calculator. Make sure that you clear the list beforehand. And we're going to enter in the data into the calculator. So 25, 40, 35, 25, 40, 60, 75. So this gives us our standard deviation, which is 17.08, which we can round to the nearest hundredth, which will be 17.1, or nearest tenth, I'm sorry, 17.1. So let's say that previous question, we could have done this in there. We could have entered each of these data sets in there, and it would have given us this right here, this 8.45. If we were looking for this number here, we could just square it. So the calculator is nice. So there is a calculator for each. Okay, so it says enter each data set into the statistics calculator. Make note of the mean, median, and the shape of the histogram of each data set. Okay, so let's look. So our first, that's the wrong thing. Let's clear this out. We're going to put in 10, 12, 12, 6, 8, 5, 4, 10, 8, 10, 12, 12, 6. Okay. So it wants us to take note. So our A has a mean of 8.846. It has a median of 10, and its standard deviation is 2.769, and it looks like it is left skewed. All right, so we got to keep that in mind. We're going to clear the list, and we're going to put the other set of data for B. So we have 8, 8, 7, oh, hold on, I messed up there. 8, 7, 9, 7, 9, 10, 6, 8. So B has a mean of 8, a median of 8, and our standard deviation is 1.095, and this looks symmetrical. And we can tell it's symmetrical because the mean and the median are the same. All right, so set A is symmetrical. No. Set B has the same mean and median. True. Set B is right skewed. No. Set A is left skewed. Yes. And the median in set A is larger than the mean in set A. Okay, let's look. The median is larger than the mean. Yes. So that should be B, D, and E. All right, let's look at question 5. Consider the normal distribution curve. Which statements are true about the curve? Select all that apply. All right, so this tells us that my standard deviation is 7. So the middle of our graph is going to be our mean, which is also going to be our median. Because it being a standard deviation, it means that it's going to be symmetrical. So the standard deviation of the data is 64. No, my standard deviation is 7. The variance of the data is 49. Yes. So how much it varies is 49, because if we were to take 7 and square it, that would give me 49. Our median is 64. Yes, that is the middle of our graph. The data point 75 is less than 1 standard deviation from the mean. Okay, so if I were to add the standard deviation to 64, so if I took 64 and added 7, that would give me 71. So this would be 1 standard deviation away. Is 75 1 standard deviation away from the mean? No. Okay, is the data point 50 is 2 standard deviations away from the mean? Okay, let's look. So if I were to subtract 7, I would get 57. If I were to subtract 7 again, I would get 50. So this is 1 standard deviation away, and this is 2 standard deviations away. So yes, it would be E. Remember, if you have any questions on this lesson, you can message me on Edgenuity, send me an email, or call me.